Hello students, now we are going to discuss the chemical properties of alkaline earth metal. In the last class already we discussed the physical properties. So chemical properties means reactivity. Already we know that you see the reactivity order is that beryllium less than magnesium less than calcium less than strontium less than barium. Okay, so generally these are the beryllium, magnesium, calcium, strontium, barium increasing order because increasing size and decreasing ionization energy. And another important thing is that the reduction potential. If you see, reduction potential also very important. The reduction potential in case of barium is barium, strontium, calcium more negative. That's why they are more reactive. So this is the reactivity. Then if you discuss the reactivity with the first thing with water. Generally beryllium, magnesium, low reactive towards water. Reactivity is low due to high ionization energy. First thing is due to high ionization energy and less negative E0 value. E0 value is low negative. If negative, that is E0 value will be more negative, reactivity will be more. This concept already discussed. So generally beryllium, magnesium, they do not react with water. But reactivity towards water is beryllium less than magnesium, less than calcium, less than strontium, less than barium. So generally metal, second group metal reacts with water in different condition. On heating, strong heating, it produce on heating, generally on heating produce metal hydroxides and hydrogen gas. But generally barium, strontium are more reactive, so producing metal hydrides and hydrogen gas action with water. You see the difference is here. Second property is action with air. Air means oxygen, nitrogen, mainly oxygen and nitrogen. Here you see the reactivity towards air, same beryllium, less than magnesium, less than calcium, less than strontium, then barium reactivity. But generally what happens, metal reacts with oxygen forming metallic oxides, and same metal reacts with nitrogen forming metallic nitride. This is the formula of oxides and nitrides. What particularly already know, the higher metals like your barium with oxygen on heating produce peroxides, barium peroxides, and strontium with oxygen on heating produce strontium peroxide. This is the peroxide because we know larger size metal produce peroxides because it becomes stable due to the peroxide having low negative charge and larger cation having low positive charge. That's why they produce peroxides. So this is the main difference between the lower metals and higher metals regarding the formation of oxides and nitrides and peroxides. Regarding this one, important thing is beryllium. Beryllium and your magnesium, low reactive due to formation of stable oxide layer. You see, beryllium and magnesium due to oxidation forming barium oxides and magnesium oxides. That's why they are very low reactive towards oxygen. These can be, they react with oxygen, they burn with oxygen only when the layer will be removed. When you remove the layer, that the protective layer, then they will react with oxygen. So beryllium, magnesium generally low reactive due to formation of stable oxide layer. This is very important. Then third one is with halogen. With halogen, generally metal with halogen on heating produce metallic halides. And reactivity is same. Always discussed. Beryllium greater than beryllium, less than magnesium, less than calcium, less than strontium, less than barium. This is the order. And sometimes, particularly beryllium oxide, when it reacts with carbon on heating, produce and halogen. Barium oxides, carbon and halogen. That is forming beryllium halides and carbon monoxides. So this is the very important specific method of preparation of beryllium halides. BX2, BeCl2 like this. And this is the main reaction of halides with alkali metals forming halides, and these halides generally ionic halides except beryllium, and beryllium halides generally covalent. Beryllium halides generally covalent characters. So this is regarding the formation of halides with halogen. Then with hydrogen, metal with hydrogen forming metallic hydrides, generally ionic, except beryllium and magnesium, generally covalent character in both. Ionic character increases. Ionic character of these hydrides increases from beryllium to what? Barium. Ionic character increases. And thermal stability, you see stability. These halides, barium hydrides is more stable than magnesium hydrides, more stable than calcium hydrides, that is increasing order. High lattice enthalpy, it has high lattice enthalpy. Which one? Beryllium due to small size. That's why these hydrides are more stable. And almost except beryllium, magnesium, other hydrides are ionic character. And these hydrides, when these hydrides dissolve in water and forming metallic hydroxides. So this is the important properties of alkaline earth metals, formation of hydrides. Then fifth one is with liquid ammonia. Like alkaline metals, alkaline earth metals reacts with liquid ammonia, forming ammoniated cations and ammoniated anions. Formation of ammoniated anions, it conduct electricity like your alkali metals, they conduct electricity, and long standing it decomposes to amides and hydrogen gas. So, but if you compare to alkali metal, alkali earth metals, almost all cases reactivity is more than alkali earth metals. Very important thing that liquid, it reacts with liquid ammonia, dissolving liquid ammonia. Then another important thing is with carbon. It has been observed that some metals, when bonds with carbon on strong heating, produce carbides, metallic carbides. And it has different formula. For example, specific beryllium carbide B2C, and magnesium carbide is Mg2C3, and calcium carbide is CaC2. Like this, different carbides are produced. These carbides more stable in case of lower member will be more stable carbides. And these carbides, when dissolved in water, forming hydrocarbons. For example, beryllium carbide B2C with water, forming methane and beryllium hydroxide. And if you see calcium carbide with water, reacts forming calcium hydroxide and acetylene gas. Hydrocarbon is produced. It depends upon the nature of carbides. And your magnesium carbides with water, forming magnesium hydroxides, and 3 carbon means acetylene, that is propylene. Beryllium carbide 1 carbon, methane. Calcium carbide 2 carbon as per the formula, that is acetylene, and magnesium carbide 3 carbon, that is propylene. So this is the important reaction of carbide with water. Carbides also highly reactive with water, forming corresponding hydrocarbons. So this is regarding the action of, and it is also observed some metallic oxides, when heated with carbon strong heating, produce metallic carbides and carbon monoxides. It also produces metallic carbides and carbon monoxide. So different types of carbides form when it heated with carbon directly, or when the oxides of metals heated with carbon. So this is regarding action with liquid ammonia. Here one thing you can add, metal hydrides and water forming hydrides and hydrogen gas. Also this is. And this calcium hydrides is called hydrolith. Its name is hydrolith, and it is used in the preparation of hydrogen gas by action with water. When it is reacts with water, forming hydrogen gas. So this is also one important, like your alkali metals, hydrides or alkaline earth metal reacts with water, forming hydrogen gas. So these are some important properties of alkaline earth metals: action with water, action with air, oxygen, nitrogens, and direct carbon, formation of carbides, formation of amide on heating also, and halides, action with halogen, forming halides with hydrogen, hydrides. So these are the common chemical behavior of alkaline earth metal due to highly reactive nature. They also react with some common reagent, oxygen, water, acids, and but it has been observed that some beryllium also amphoteric nature. You can write this one: action with air, action with acids, not written. You can write here action with acids, that 6, 7 with with alkali, with acids and alkali. Some reactive metals also, that metals react with acids, hydrochloric acid like it, forming halides, and let it be chlorine taken, chlorine, and hydrogen gas is produced. Almost all metals react with hydrochloric acid, forming halides and hydrogen gas. But beryllium is amphoteric character. It reacts with acid, forming hydrogen gas, and also reacts with the base in presence of water, forming salt, sodium berylate, Na2BO2, Na2BeO2 plus hydrogen. So beryllium is amphoteric character. It reacts with acids and also reacts with base. So generally, alkaline earth metals will react with dilute acid, forming hydrogen gas, because due to low reduction potential. As reduction potential is low, as their ionization energy is low, so they are also reactive towards acid and bases. But particularly beryllium reacts with base, not others, due to amphoteric character. And but if you compare with alkali metals, the all reactivity is slower than the alkali metal, because alkali metal is large size and very low ionization energy. So this is the important explanation cause that why alkali metals are more reactive than alkaline earth metals. So this is regarding the chemical behavior of alkaline earth metals. Next class we will discuss the important properties of the compounds of alkaline earth metals. Okay, thank you all.